Welcome to our very first lecture. We will be beginning our course by studying nuclear physics and radioactive decay. In our study of physics, chemistry, as well as science in high school, as well as our previous courses, we have seen the model of the atom where we have a positively charged nucleus that is surrounded by the negatively charged electron cloud. We also know that the physical and chemical properties are due to how the electrons are arranged or their configuration around the atom. This arrangement of electrons is also responsible for chemical bonding. In this course, we will turn our attention to the properties of the nucleus and see some of the cool things that can happen with just the nucleus alone. So in this lecture, we will be focusing on the basic model of the nucleus. We consider the nucleus to follow the particle model, but it is important to keep in mind that at these small length scales, the nucleus really should be treated as a wave. So here is the model we have. The nucleus, and inside it, we have a positively charged particles as well as neutral particles. The positively charged being protons and the negatively charged being electrons, which are actually outside of the nucleus and not shown in the diagram. But the neutrally charged are called neutrons, which are solidly colored black in this diagram. Also note that the diameter of the nucleus is approximately 10 to the power negative 15 meters. So the nucleus is composed of Z protons and N neutrons, with the protons having a mass of 1.67262 times 10 to the negative 27 kilograms, which is equivalent to 1.007276 unified atomic mass unit, which I will explain later, and it is positively charged. The neutron, on the other hand, has a mass of 1.67493 times 10 to the power negative 27 kilograms, which is equivalent to 1.008665 unified mass units, and it has no charge. And just a bit of history regarding the neutron. It was first discovered in 1932 by James Chadwick in the form of radiation that was emitted when light elements were smashed or bombarded with the helium nuclei, or also known as alpha particles. The total number of neutrons and protons is what we call the mass number A, and can be summarized in the simple formula A is equal to N plus Z, where Z is the atomic number or number of protons, and N is the neutron number. And when we refer to neutrons and protons collectively, we call them the nucleons. Also note that the easily measured properties of nucleons are its charge and mass, which is why Z and A are really basic. If you are given a nuclide, or any nucleus, then we often denote it with an associated element and its mass and atomic numbers are attached like this, where X is the element symbol from the periodic table. For example, carbon is written as 12C6, which means carbon has 6 protons and 6 neutrons. And it is important to remember that the neutral atom is the basis for the unified atomic mass unit U, where we have defined the mass of one neutral C12 atom as being 12U. Another example is nitrogen, which is written as 14N7, which means that nitrogen has 7 protons and 7 neutrons. But it also has a heavier form, which is 15N7, which is 7 protons and 8 neutrons, as well as a lighter form, which is 13N7, which means 7 protons and 6 neutrons. But just as long as it has 7 protons or a positive 7 charge, then it is a nitrogen nucleus. The different forms are called isotopes of nitrogen. Atoms of nitrogen made with these different nuclei will have nearly the same chemical and spectroscopy properties. However, importantly, it is the nuclear properties that can be substantially different.